Good morning, children. This is Pawan Kumar, and today we will study Units and Measurements chapter, which is chapter number 2 in your Physics Part 1. In the previous class, we studied about fundamental quantities as well as derived quantities, and after that, we studied about fundamental units, which are also known by the name base units, and along with them we studied about derived units, right? About fundamental units you studied very well in a manifold way, that fundamental units are 7, which are units of seven fundamental quantities. Let us revise it once, that which fundamental quantities we studied in yesterday in the previous class. Those 7 quantities were: first one was mass, second one was length, third was time, fourth was temperature, fifth was electric current, you can say electric current, sixth was luminous intensity, okay. And after that you can say the last one, seventh one, is amount of substance. You can write them on any number, it doesn't matter on which number you are writing, but the quantities will remain same. That means the 7 quantities will remain same. Mass unit was kg, length unit is meter, time unit is second, temperature unit was Kelvin, electric current unit is ampere, luminous intensity unit was candela, amount of substance unit was mole. I have written their symbols like you can see here. So what we can say that we have seven fundamental quantities, and 7 only, and these 7 only we have fundamental units, right? So we studied in a manifold way about all these things. Let us see few more things about derived units, right? Let us take some example, and then you will have sufficient knowledge about all these type of units. Derived quantities I have written. So what could be an example of derived quantity? First of all, what are derived quantities? Derived quantities बच्चों वो होंगी which we can obtain, जो हम प्राप्त कर सकते हैं from the fundamental quantities, right? All those quantities are called derived quantities. Like example you can say speed, you can say acceleration, then you can tell what example you can set here. Yes, energy you can say force, right, etc. All these quantities are best examples of derived quantities, because you are familiar with all these terms as you have studied them in class 9th, right? Now if suppose you are writing speed, then in what unit you will write? In which unit you will write speed? You will write speed in meter per second. Also in our day-to-day life we see many examples written in this unit, kmph, that means kilometer per hour. But the thing is, kilometer per hour is not the SI unit. What is SI unit? Meter per second. After that you can take acceleration as an example. The unit of acceleration is meter per second square, right? So here you have seen these two examples. One is meter per second, another one is meter per second square. all these are examples of derived units, right? Because these are the units of derived physical quantities, so these units will be called derived units. Now let us look how we can say that if speed, we are saying it is an example of derived quantity. First you understand it how it will be a derived quantity. The formula of speed is, you know very well, it is distance upon time. Now distance is what? It is a type of length, and time we can write as it is. Now you look here, if you look on length, then it is an example of fundamental quantity. Time, it is also an example of fundamental quantity. Because both the things are fundamental quantities and these things are coming in the formula of speed, that means speed is made up of these two things, right? Then what we can say? We derived speed with the help of these things, right? That means it will be a derived physical quantity. It will be a derived physical quantity. In this way, speed or acceleration, force, energy, power, all these we can set as example of derived physical quantities. So I hope you understood very well. First of all, we have taken example of fundamental quantities and units. Then I have shown derived quantities, their examples, their units, and how they will be called derived units. This also I have shown. Okay, now we will study few fresh things today. What are those? Those are measurement of length. Measurement of length. This will be our topic of discussion today. In measurement of length, you know very well that children, there is a scale. That scale is known as meter scale. Okay, now how a meter scale looks like? It is just like a scale you have in your geometry boxes, right? The difference is this scale will be of wood and the markings you will see on them will be from 0 to 100 centimeter, right? That means the total length of this meter scale will be equal to 1 meter, and so the name is given meter scale. Now what can you do with the help of meter scale? हम मीटर स्केल से क्या कर सकते हैं भाई? सीधी सी बात है, मेजरमेंट कर सकते हैं. बट what is the range of that measurement which you can do with the help of meter scale? So meter scale minimum it could measure 10 to the power minus 3 meter to a range, to a particular range only it can measure, and that range is minimum is 10 to the power minus 3 and the maximum is 10 to the power 1 meter. 10 to the power 1 meter, sorry it is wrong. Here what will come? Here 10 to the power 0. 10 to the power 0 means 1, right? 10 to the power 0. This is the range which can be measured with the help of meter scale. Now you try to understand what is this 10 to the power minus 3 meter. 10 to the power minus 3 meter is, you can also call it 1 millimeter, right? 1 millimeter. If I take an example, then you consider this scale is same which you found in your geometry box, right? 15 centimeter scale. So here what you will see, 15 centimeter, and there this side 0 centimeter. After that you will see 1, 2, 3 like this. Am I right? And it goes up to 15. Okay, Now between 0 and 1, you see several small lines made over there, marked over there. Am I right? So how many lines do we have here? We have 10 lines, and each small line represent 10, not 10, 1 millimeter, right? 1 millimeter. Look, this 0 1 2 3 ये सब क्या है, मीटर सेंटीमीटर में है. अब ये जो मार्किंग है ये इन वाली मार्किंग से भी छोटी है. कौन सी वाली से? ये मार्किंग किसकी है आपकी? 0 1 2 3 ये सेंटीमीटर्स में है. ये वाली जो मार्किंग है ये उससे भी छोटी है, तो यूनिट भी तो उससे छोटी होगी ना. अगर 0 1 2 3 ये सेंटीमीटर में है, देन इट इज़ वेरी सिंपल टू say here that these small markings represent 1 millimeter. One small line represent 1 millimeter. That means minimum, what is the smallest length? Not minimum, what is the smallest length which we can measure with the help of this scale? We can say that after 0, the very first line, up to there we can measure. इसका मतलब ये है कि कम से कम हम 1 मिलीमीटर मेज़र कर सकते हैं. एंड इफ़ यू कन्वर्ट 1 millimeter into meter, then it will come 10 to the power minus 3 meter. तो वो कितना आएगा? 10 to the power minus 3 meter आ जाएगा. ठीक है, इतना हम कम से कम मेज़र कर सकते हैं. अब ये क्या चीज़ है देखिए, यहाँ पर जो ये रेंज लिखी थी कम से कम मेज़र करने वाली, इट इज़ सेम 10 to the power minus 3. अब ज़्यादा से ज़्यादा कितना मेज़र कर सकते हैं भाई? You all people will say, sir, the scale has a maximum range of 100 centimeter. That means 100 centimeter only we can measure, right? So maximum we will say we can measure 100 centimeter. लेकिन बच्चों 100 centimeter is equals to 1 meter, and if you write 1 meter in terms of power exponential form, how can you write? You can write like this, 10 to the power 0, it will be 1. Sorry, that's why children, I have written with the help of this and this, I have written the range of meter scale, that it could measure from this to this meter. Okay, I hope that now you would not have any problem in understanding this range. अब ये मीटर स्केल तो इतना मेज़र कर सकता है, ठीक है. अगर हमें इससे भी स्मॉल, सॉरी ये नहीं, ये इससे भी स्मॉल अगर मेज़र करना हो, that means even smaller than 10 to the power minus 3, then with the help of meter scale we cannot measure. Then what will we use? तो बच्चों इसका जवाब ये होगा कि अगर हम इससे भी कम मेज़र करना चाहते हैं, कर सकते हैं, बिल्कुल कर सकते हैं, लेकिन वो डिवाइस आज आप पहली बार मेरे ख्याल से उसका नाम सुनोगे, एंड दैट डिवाइस इज़ वर्नियर. इट इज़ वर्नियर calipers. Vernier calipers. Children, it is a device which has got name on the name of scientist who had done the study that it is a device which can measure even less than 10 to the power minus 3 meter. Okay, let me see if there is any figure. Figure means like a picture of vernier calipers. If I found somewhere, I will show you. Okay children, so you can see this is the figure of vernier caliper, picture of vernier calipers. Children, remember in vernier calipers you have two scales. You have two scales. One is known as fixed scale and one is movable scale. The details of vernier calipers we do not have to study in our text. it will be studied when we will perform practicals. Okay, it will be very helpful instrument in the experimental section of class 11, right? So here we will have basic knowledge of vernier calipers only. The thing is that how much what is the minimum limit what is the minimum limit which we can measure with the help of vernier calipers, right? What is the minimum length we can measure with the help of vernier calipers? So remember children, it has a least count. It has a least count of 0.01 centimeter. Now what is least count? It is again a new word for you. Least count, for now you can understand it in a simplified way, that least count is the minimum possible minimum possible limit, you can say, which can be measured. Yes, which can be measured. You can say this for a while to least count, that it is the minimum possible limit which can be measured with the help of any instrument. Like of vernier calipers, least count is 0.01 centimeter. That means if we will write in centimeter, sorry, it is already written in centimeter, I mean in meter, then it will be something 0.01 into 10 to the power minus 2 meter, right? And if you adjust this decimal again, then you can say 10 to the power minus 4 meter. Okay, so now you can see, in the previous case we have seen we could be able to measure up to 10 to the power minus 3 meter only, but with the help of vernier calipers we are able to measure even 10 to the power minus 4, right? So this is the thing which I have shown you here. Now two instruments we studied with the help of which we can measure length. One we have seen meter scale, right? Meter scale. And the other I have shown you vernier calipers. Okay, these are the two instruments which we studied. Now if we want to measure even smaller than 10 to the power minus 4, in that case what will we do? So that we will see in the next video. Till then, you take care and keep revising.